Okay, so we're going to learn how to calculate R for our gas law lab. So the first thing you need to know is this is not the data you'll be using, nor is the data you see on the videos, but what you need to do is look for the dry lab data from the student dry lab data file. It's in an Excel file and look for the tab under gas law, okay? So the values here are a little different. So your number on the dry lab data will be a different number here. All these numbers will be a little bit different, so please make sure you're not copying directly, but I'll show you how to work it. So this is trial X since it's not either 1 or 2 that you were provided. Now, 40 milliliters is what you were released from the burette, and then you measure whatever that number is in your eudometer tube reading. Okay, so the tube reading says 41. So basically, there's a conversion factor of 40 mils over 41 mils, and that comes up to 0.9756 over here, because the F ratio is given as basically your real volume over your ET reading volume, okay? So you have this factor here that's conversion factor. So whenever your trials value here, it says 41.6, we have to convert it to what it really is in the burette. So we'll have to use this value here, the F factor. Now the F factor that you have will be a little different. So just keep that in mind. So basically the real volume over here will be based on the fact that you have to use your conversion factor. In my case, it's 0.9576. So to find the real volume of hydrogen gas, I'll have to take 41.6 mils because that's my value. And I'm keeping 4 sig figs here. So that multiply with my F, which my F is 0.9756. And then that's in milliliters, and I'm going to convert it to liters. So 1 liter has 1,000 milliliters. Okay, now that's going to give me an answer of, it's going to be a long number, but I'm going to keep 4 sig figs. Okay, so in 4 sig figs, it's going to come up to 4058 times 10 to the minus 2 liter. Okay, now that's for the volume, and then the temperature here is 25 degrees Celsius plus 273, so we will get 298 Kelvin here. And then we'll also have the next value, we need to get moles of hydrogen. Moles of hydrogen here, we're going to use moles of magnesium to get it. Okay, so the mass of magnesium that we used was 0.039 grams. So whatever grams of magnesium that you end up using. In my case, I have 0.039, and then I'm going to multiply that with magnesium's molar mass, because 1 mole of magnesium is going to weigh 24.31 grams of magnesium. So it really is divided because 1 mole is on the top, the grams is on the bottom. And then I also need to know that magnesium to hydrogen is going to be a conversion ratio where 1 mole of magnesium will give 1 mole of hydrogen here. So we will get an answer of 1.6. We have to keep just 2 sig figs here because of 39 here is 2 sig figs. Okay, 1.6 10 to the minus 3. And then once you have the moles here, what we're going to do to solve for the pressure here, you have to take the total pressure minus the water vapor pressure. This value here is found from the appendix where you look for the 25 degrees Celsius and you'll get this water vapor pressure. So the pressure of hydrogen gas is a dry gas, so you have to take the total pressure minus this water vapor pressure, and then you have to convert it to ATM. So we'll do 760 torr minus 23.756 torr. Okay, whatever that value is, we'll do that on a calculator, and then we'll take that and convert it over to 1 ATM is 760 torr. So you have to do this on the calculator first. So on that one, 760 minus 23.756, we get 736.244 right here. So let me write that on the bottom, 736.244 torr. So this is the answer that you get down here. So take this number, divide it by 760, and we'll get a value of 0. So this is an exact conversion. So the sig figs we keep is whatever we have here, which is still about 6 of them. So 0.968742. This is ATM. And then we'll use these values here to determine R. The formula we use is PV equals to nRT. So R equals to PV over NT. So our pressure here is that value here. So let me put it in 0.968742 ATM. The volume is in liters, this value here, 4.058 times 10 to the minus 2 liter. And then N is number of moles, which is this right here, 1.6 times 10 to the minus 3 moles. And then our temperature is 298 Kelvin. We'll go ahead and solve for R. In this case, you're pretty limited with the sig figs here. So we'll end up getting, when you put all this in the calculator, you get 0.082 ATM liter moles Kelvin. So that's an example of how you do experimentally determining R. And then basically we already know R is about 0.08206. So the fact that we got this value, that's pretty good. So let's see what your dry lab data will give you for your trials. Hopefully this helps.